Our next speaker will be President James Liao from Academia Sinica.
Well, we heard a great talk from Professor Chu, and Professor Xie that brought us down to the local issue, electricity price. And I'm going to also bring down the whole climate change issue to the local level. As we know that climate change is a global problem, but energy policy is local. Okay, so let's look at the greenhouse gas emission in Taiwan, where we emit 286 million tons of CO2 equivalent a year. This is the latest news, latest statistics. I think it's accurate, but may probably miss quite a bit. And our composition is very different from the rest of the world because we use a lot of electricity for manufacturing. Okay. Here we see industrial electricity, household electricity, service sector electricity, manufacturing, construction, this is the energy usage, and transportation only 12%. Agriculture actually surprisingly small. I don't know if it's accurate or not. But the bottom line is energy usage accounts for 90%, 91% to be exact, of emission, energy usage. Now, let's look at the energy usage, which accounts for 90% of our emission. Among that, we separate from electricity and non-electricity. Electricity accounts for close to 60% of emission. So that's why electricity is very important. Professor Chu said it, and Professor Xie said it. Among the electricity, who is using electricity? Industry use 32%, household use 11%, service industry use 10%, energy sector itself use 4%, agriculture use 1%. Okay? Non-electricity usage, what is that and who is using that? That's transportation. Currently, our transportation accounts for 12% of our emissions, and most of them still use liquid fuel, not electricity yet. Manufacturing and construction, direct burning of coal or natural gas for heat or for other energy usage, and solid fuel manufacturing, and refinery accounts for 3%. Refinery itself, not the associated part of the emission. So these are the non-electricity usage. Let's zoom into transportation. As opposed to many other countries, transportation emission usually accounts for more than 20%. In the United States, probably 25%. In Taiwan is 12 or 13%. Road transportation is 12%, almost entirely transportation. Railroad, domestic aviation, domestic marine transportation accounts for the remaining parts. Road transportation, motorcycle accounts for 1.6% of emission. But it's associated with a lot of air pollution, as Professor Chu mentioned. Small vehicles, 6%. So half of it comes from small vehicles, buses, small trucks, and large trucks are the remaining parts. And the solution probably is what we already know, electrification. Except for large trucks, and Taiwan doesn't have a long-distance, long-haul trucks as in the United States or in Europe, but still, we may need that. So it's a small need for using hydrogen as a fuel. Okay, so the remaining part of the 10%, this is where electrification does not help. It comes from chemical industry, mining, and metal manufacturing, semiconductor manufacturing. And this chemical industry, these are not energy usage. These are the emission comes from processes. And it's very difficult to change the process, or almost impossible. In semiconductor, that emits the greenhouse gas because they use a lot of fluorinated chemicals. So decarbonization of electricity generation is the key in Taiwan. Okay. Now, but let's compare our situation again with other major countries. The energy usage is the major source of emission. This is true for most of other countries. Taiwan accounts for 90%, Germany 88%, Japan 92%, US 87%. So this part is the same. Among the energy usage, Taiwan electricity accounts for almost 60% of the emission. Transportation only 12%. Germany 31% or 21%. Japan is closest to us. Electricity accounts for 43%. Transportation is 17%. And the US electricity accounts for 28%, transportation 30%. This may reflect possibly two things. One is we have a strong manufacturing industry that use a lot of electricity. Secondly, we probably didn't do a good job in decarbonizing electricity yet, as opposed to California, for example. Steve just said that California already use huge amount of renewables and even have negative price for renewables during the day, which is totally inconceivable in Taiwan, at least for now. Probably also for the future, forever, will not have that. I'll tell you later. This is the why. The area per capita, Taiwan is this little. US is Taiwan's 20-fold higher area per capita. Australia is almost 200-fold higher, and we have the same amount of population as in Australia. 23 million people live on Taiwan, 23 million people live on Australian continent. Okay? We just don't have enough land to harvest solar energy. So this is the difference. This is why we will not have negative price during the day when you have generate a lot of electricity. And carbon emission factors, this is the CO2 equivalent emitted per kilowatt hour. Okay, Taiwan is about 0.5, middle of the road, a little bit better than China, worse than Singapore, Korea, Vietnam, or Germany, or United States. Okay. So this is where we need to work on. We have to bring down our emission factor in power generation. So let's look at the electricity. Who's using electricity? As we said, industry uses the majority of our electricity. Household and service industry are less. Who in industry are using electricity? Okay, majority is semiconductor manufacturing, but that's our national security shield. It's called the chip shield, right? So this is where we get a major part of our energy, the national security comes from. Chemical industry also emits quite a bit, about 10%. This is the energy part, not the materials part. And also there's basic metal manufacturing. So these are the big three in industry. And then let's look at the very real problem, okay, in numbers. How much energy do we use? How much electricity we use? We use 280 terawatt hour. Okay, each terawatt hour is 10亿度. We use 2800亿度. 2800亿度, 去掉一个零, 叫做 terawatt hour. 280 terawatt hour. That's how much electricity we use. Where we get electricity from? Coal, it's 120 terawatt hour. Gas, 110 terawatt hour. Remaining parts of nuclear, this is probably less now. Today, probably zero, because we probably don't have anything now. Renewables, 27. This includes wind, solar, and all other hydro. So if you look at, if we want to decarbonize, it's 280 terawatt hour. Even if we expand our wind and solar combined to 1000亿度, the 100 terawatt hour. This is probably the maximum we can get in Taiwan in terms of renewables. Plus, if we extend our nuclear power plant, the He Hesan, the second and third nuclear power plants, accounts for 31 terawatt hour, or 310亿度. We are still short of about 150 terawatt hour that needs to come from somewhere. Okay, Not to mention that very soon, our energy demand, electricity demand will go up from 2,800亿度 280 to 500 terawatt-hour because of electrification, because of data centers, and so on and so forth. Okay? All these white bars are what we need to work on. So where do we get this electricity from? These are some possibilities. Gas plus CCS. Okay, but we know that CCS is a major difficulty in Taiwan, particularly in Taiwan. We just don't have land for store those things. Perhaps we can ship to other places where they have oil well, maybe Indonesia, Palau, or even United States, in Europe, and so on and so forth. Another one we propose for short-term storage, for short-term solution is methane pyrolysis to crack methane to carbon, solid carbon, and hydrogen. And this requires much less energy than water splitting. And carbon can be used later as many industrial materials. This has some problem, but also has some promises. I will explain that later. And then geothermal, and we have started drilling a deep well geothermal below the 4 kilometers. Taiwan theoretically has a lot of geothermal energy, okay, that we can tap into. And the ocean current energy, not the tidal energy. The crucial current energy, which is very strong in the eastern part of Taiwan, is very difficult, but it's available. It's not something we can do it overnight or even next 10, 20 years, but I think 30, 40 years later, it's a possibility. Okay? Not immediately. And then the rest, we have to rely on new nuclear power plants. Even if we cannot satisfy that, maybe SMR probably come earlier. And then very last, we'll have to rely on imported hydrogen or ammonia. Okay, so this is what we propose in our policy recommendations. These are all the possible technologies. So this is the methane pyrolysis to produce hydrogen, and we use the hydrogen for power generation and use the solid carbon for materials. And even, as Steve mentioned, you can make into carbon conductors that can replace copper. Of course, it's not carbon black, but you have to process that, but you have the raw material. It's a very pure carbon, okay? If the whole world is using this, we will have too much carbon. But if only Taiwan using this, we make a lot of money, okay? It can even subsidize for the electricity price. Geothermal, as I mentioned, marine and high efficiency. By high efficiency, I meant more than 30% of efficiency, which in small area, we already accomplished that yesterday in our lab, but we need to scale it up. And biomass carbon sink. And of course, all these things are what we are already doing. And then we had to think about whether we want to continue nuclear or build new nuclear power plant or new CCUS possibility. And the rest, I don't have time to talk about it, so I will stop here for further discussion. Thank you.